Hello and welcome back to Compiler Programming. Today I want to start taking small steps in the direction of debugging. So whenever we git compile the code, there is this exception handler function that allows us to get the exception, and right now the only thing I'm doing here is I'm printing the stack trace essentially. So first of all, I print the type of the exception that happened, and then because in here I'm doing return exception continuous search, that means that the exception handler will just go back to the wrapper function, the caller, and then it will try to find a handler there, then up, up, up. Eventually it will not be able to find one, or will be able to find one, and depending on that, the handling will happen. And the way it's used is here, if we search for try, so there is this test exception handling, and we define this exception handler in here, and then we call our git function. So inside of our git code, there is no exception handler, but in here there is one. So this is what we do in the handler. We say everything is okay, and then we check that everything was fine. And if we run that code, so if I do a test, compile, we actually see what that does. Oh, that's interesting, something I need to clean up. But anyway, this is the code in question. We have an handle exception integer divide by 0, and then we have these stack trace entries. And the way these entries work is because here I take the address of the instruction and I use the information that was gathered throughout the compilation to actually resolve this instruction to a particular location in the source code. In this case, it is line 130 and line 219. And if we look into here, actually I need to open this file, runtime divide by 0. That is exactly what happens, right? So if we look at the location here, so here you can see line 130 and then line 219 in the corner of my lower right corner of my editor. Yeah, so the location is correct. We did encounter exception here, and then we go up the stack and we say that actually it was here, and then the code proceeds back to the test harness, and this is where this checker is equivalent to this main function. So this is what happens, and this was pretty good for what it was, but now I actually want to start taking small steps into actually being able to debug the situation. I'm not sure yet if I will go with something like command line like GDB, or I will just straight up go into graphical user interface later. But for now, all I want to do is being able to print some information about what is the state of the program at the point of the exception. And there is a bunch of stuff that can be printed. So in here, there is the MSDN documentation for the parameters that we get. So here's the parameters. There is exception record, there is establisher frame, there is context record, and dispatcher context. And all of these structs have a bunch of fields. So now we can actually print some of them. So let's actually do the context, because this is the most low-level one, and I'm not too sure I understand all of them. I think these fields are memory addresses of the places where we store the what's called home area of the argument. So whenever you call a function, if the debugging is turned on, you store the original value of the register in this home area, so you know what was the value at the time that the function was called. I know it sounds a bit confusing, but we'll get probably not in this video, but later on we'll definitely need to make use of it. I'm not sure what context flags are. This also not clear. I need to research this. These are segment registers, CS, TS, CS, and so on. I think out of those, mostly we'll probably only be interested in JS when we get to thread stuff, but for now, I don't think we really care about these that much. eFlags is the flags register. This is extremely useful. It will show what is the state of like if we did a comparison, what was the result of that comparison, and stuff like this. I think these are debug registers. I have no idea how exactly to work with them, so that's something I need to investigate myself. And these ones should be already very familiar to you if you have watched some of my videos on x86 instruction encoding. So these are just general purpose registers that x86 64 processor has. So these are x86 and these are extended x86 64. And then you have instruction pointer. And then you have, so this is a bit awkward. The Windows supports also ARM processors. So that means that you have different types of vector registers. For the x86 64, you have these XMM registers, right? And then for ARM, you have Neon. So this is why this is a union, right? So you have either ARM stuff, or you have, I mean, you have to have the information about what the register says. You have ARM. I have no idea what D is. It's the most undescriptive name in the universe, I guess. I think Q is treating it like quads, and this is treating it as that. I don't know. Whatever the thing is, I'm not exactly sure about this. I need to look at some debugger code, maybe open source one. I don't know. Anyhow, this is also not really documented what that is, but these are obviously XML registers. And then there is vector control, which I think is something like eFlags, but for vectors, but I'm not sure. And then there is a bunch of other stuff. Right. The point is, right now I will only focus on some of these registers. So I'm interested in printing these ones, and then I guess eFlags, and I'll consider if I want to print XML ones later. So we'll focus first on the general purpose registers in this function. Right. So I guess we'll do it here. So what we'll do is we will say print register state, and we'll prefix is with Win32 because this is very specific to Windows. And we are going to pass context record, right? So we'll say Win32 and then print register state. Again, it will get this as an argument. It doesn't return anything, and I will not worry too much about formatting right now. I just want to get information out. So what we'll do is I will guess we start with reap. So let's do the following: printf, and we'll say reap, and then 0x percent 16x. I guess that's the correct way to do it. Like this, maybe. And then we say context record reap. So first of all, does that compile? And signed int, yes. Yes, LLX. Okay. So that should be fine. I want a new line there. And let's try to run our tests again. Maybe to run less of them, we will actually do focus. Okay. And great. So we actually do get what we want. We have rip 0x. Formatting is not exactly correct. I think I need to say this 016, and I guess is that maybe we will print it here instead. Yeah, that sounds better. Okay, let's try it again. Right. So we have rip address. So this is actually the address of the code that we are executing. And I think it will stay stable or not. Yeah, it is randomized because executable is randomized. So because we have process layout randomization in Windows, including our JIT code. Actually, our JIT code is randomized because we just allocate memory. Okay, yeah. Anyhow, this will be different every time we run, but that is not really important. But we now are ready to print all the other registers. So let's do that. That will be unfortunately quite copy-pasty. Maybe later on I will create a macro enumeration or X macro for this, but for now I'm just gonna bite the bullet and do this. I know that's not very nice, but unfortunately at the same time the C is not great at all at doing macro programming, so you know, it is what it is. RCX, RBX, RSP, RBP, RSI, and RDI. Okay, so these are the first 8, and then did I miss one? Yes, I did. I missed RDX. Okay, another 8 of them. Great. That's good. Let's make another 8. And that would be R8, R9, R10, R11, R12, 13, 14, and 15. Okay, here, here. No, not very exciting work, and I definitely need to improve my editor to support this kind of tasks better, but for now I have what I have, so bear with me please. Okay, RGI, and here I would need to edit it manually anyway, because I want different capitalization. RBP, RSP, RBX, RDX, RCX, and RAX. Great. Maybe I actually should... Well, I'll do cleanup later on. I might want to create a helper function for this type of printf. But for now, let's run the test and see our registers. Okay, so first of all, let's align this a bit so it is easier to read those. And right, so this is pretty much what we wanted. Now we have nice information here. So we know the state of each of the registers, and if you saw the window in MSVC, this is exactly what we get. Let me show you what I mean. Def env mess solution. Visual Studio, you can do it. Okay. So let's make a breakpoint, for example, here. I will run the code. Build, and here's the breakpoint. Okay. So if I go now to this window, which I will now put in here. So this is sort of exactly the same thing as what we have, right? The only difference, it has this EFL, which I'm not exactly sure what it is. Okay, so this is the extended flex. But I think I want to print it differently. I actually want to print, maybe okay, so there is this flex. Yeah, okay, right. And we can do, so these are sort of the same values as we saw in that struct, right? So we have CPU, which is these general purpose registers. If we turn on CPU segments, these are CS, DS, and so on, and we can, I'll take a look back in this. Let me try to arrange this somehow so it's visible. Both of those. Yeah, right. Okay, that's great. I like responsive websites for this purpose. Anyhow, so again, these CS stuff is exactly these things here. And then we have our general purpose registers. There is this extended version of, so there is raw version of eflags, 0024, whatever. So this stuff here. And then there is, you have also them printed like this. I actually don't like how they are printed because the names here are somewhat non-standard for whatever reason. So I might change the names, but the point is they're the same. And now you know how this register window works, more or less. I mean, you also need to know what happens inside the kernel, and for that, I guess, watch some of the Andreas Kling videos about his own operating system. I will link it in the description. But the point is, so whenever you switch a thread from one to another in the kernel, you also save the state of all the registers. So the kernel has a code to just take the registers and save them into a struct, and then this is exactly the struct that we get. Okay, so eflex, right? Eflex. And eflex again is a D word, so that means that it is, I need to just do 0.8 here. Eflex. And maybe let's do a separator here so it is slightly easier to read. We'll have a new line. Okay, so now we'll have raw eflex value. I can kill this. We don't need this anyway because debugging exception handlers is a nightmare anyway. Eflex is not a member. Yes, because I misspelled eflex. It's supposed to be like this. Okay. And yeah, now I'm saying eflex. Right, because it's not LX, it's just X. But periodic argument has type what? Has type T-word. And I thought that X can do... Huh? Yeah, that shouldn't make a difference. So I'm not sure here. I'll just cast it to U32, I guess. That should still be fine. Well, that seems pretty reasonable to me. Okay, so now we need to print individual flags. For that, what do we do? Well, for that, it's gonna be bright now, so brace yourself for that, because we need Intel architecture manual. And we go to E flags, maybe something like that. That seems like a completely terrible search. That's not searching anything. Okay, that seems better. E flags, E flags. Up, 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 up. I want the description of the register itself. Can you get me that somehow? So, yeah, maybe. Intel architecture manual is not being very cooperative. So what if I search for flags register? Okay. This is what I'm interested in. Let's take these. These are extended flags. Just copy paste this stuff. And let's print that. Okay. And what do we do? Well, we say printf cf is percent. Well, we just need one, right? So that will be percent I guess. And then I might think about how to present it better, but for now, we'll just take this and then we do that, and then we end it with the mask that we have here. So carry flags, this one we can skip. Parity flag is not very useful. It's not used now in modern code, I guess, but that's fine. Adjust flags, so that's carry or no carry, so it's auxiliary carry. Okay, F is 8. Then we have the interesting ones. Then we have a 0 flag, which is 40. Sign flag, which is 80. Then we have what we have? Trap. So trap, I think, is never actually going to be... Well, no, it is. We'll get to trap at some point, because this... So the reason you need this trap flag here, and we will use it in the debugger, is because it allows you to single step an instruction. Like, you set this flag on the processor because this context record actually is not read-only. Whenever we get an exception, we can read stuff from here, which is exactly what we're doing, but we can also write back to it. And if we write back the trap flag, for example, we set it to 1, what the CPU will do is after every instruction, it will trigger another exception. And the exception that it will trigger is here, single step instruction. So this is the branch that we will end up in if trap flag is set. Anyhow, we have TF. IF should not be really interesting to us, but it's an interesting attack vector, I guess. So there was a video about that on Serenity OS. It's quite interesting, so maybe I'll link to that. And right, we have direction flag. So DF is 400 hex. And we have IO privilege. I'm not gonna go into that. And is the task flag, not interested. Reserve, not interested. Resume flags, I guess not interested. Virtual mode, alignment check. Essentially, at some point we will want to also deal with CPU ID, but for now, all of those is not interesting to us really. So last one that I need to do is OF. And I guess that is about that. Actually here I need to do something like that. Because I need value 0 ON, and this just checks for, like, this applies a mask, and that means that if we print it, we will not get 0 ON. Okay. So let's comment it out. Let's try to build. Building seems to work. Let's try to run this stuff. Okay. Well, that's pretty good. I'm missing the new line, and I guess, like, I'm not really stoked about the representation here. So let's actually print it in a nicer way right away. So how do I want to do that? I guess what I want to do is I want to store them into variables. So I say bool cf, right? And then pf, af. It's a very copy-pasty code, but what can you do? tf and ef, df and of. All right. This is nicked by. It's not necessary. So 400, 200, 100, 80. I messed up somewhere, didn't I? Oh no, no, everything is fine. Okay. So the way I want to print them is actually slightly different. I will print them as a table. Okay, so this will be CF, PF, AF, ZF, SF, TF, EF, TF, and OF. Actually, I don't think I will even need these. or no, I'll leave them with F, even though F is repeated in every place. Okay, so that's the header. Now we'll just do this, and we are going to do this. So we will print %i. I'll actually do 2i. And probably I could have done it somehow better by putting them into an array or something, but it's fine. What's important is the end result. And here we can do CF, PF, AF, ZF, SF, TF, IF, DF, and OF. We can even speed this out so it is nicer to track them. And here we go. Okay, that actually will be a bit nicer, I think. Let's see how it looks like. Right. Would not hurt to add some new lines in here. Okay, that's much, much better. Although I'm not sure if I want them aligned to left-hand side or right-hand side, but whatever. And actually, now that I'm thinking about it, I don't want to have maybe I do want to have C, and I want to put an X or a space in here. So we'll do CF X or X space, something like this. Define X flag, and we'll just do it as a macro, I suppose. Okay. Right. That seems okay, although do I really need a macro? Right, I think it's time to clean up this even further. So what I will do is I will say struct flags, or not like this, struct, and then we would have the name, or like this const char star name will have bool value. That seems legit. Flags. So if you don't know, in C you can actually put the struct like this in line. You cannot refer to this struct in any way, which is quite sad. Like GCC actually has a type of operator which is non-standard, and then you can just use anonymous types everywhere you want. So this would be pretty neaty, but unfortunately MSVC does not have type of, so that kind of sucks. Right, and then what we do here is we will do this, and then we say, what do I want to replace it with? I guess I want to say dot name equals this, right? And now I'm saying value is this. Okay. Good. Don't need this extra space over here. And we don't need the comma here. Instead, it should be actually like this. Okay. So now we will have the data in a form where we can actually work with it slightly better. And we will do for u64 I is 0, I is less than count of flags, plus plus I, all the standard stuff. But because we can't name the type, we can't actually extract a single record, but we can refer to individual fields pretty easily. So what we will do is if I is not equal to 0, then we do printf this, I guess. And then we print f and type flags I dot name. Actually, I will need %s for that. So what I'm doing right now is I'm printing the header of this. Doing a separator now will be slightly more annoying because we need to measure how long it is, so how much we printed. It's also going to be pretty inefficient, but okay. So let's do length is 0. Length plus equals there len. Actually, we can do count of, I guess. That should work. And then I will do length, or maybe strlen is better for consistency. I think compiler will actually inline it anyway if you're doing optimized build and it is a non-string. Okay, so this is the table header. Okay, now we will do very inefficiently separator. Like this is definitely not how you want to do it, but you know, can help it in this case. Printf /n, put char, and we'll do like this. I don't know if that will work, but we'll see. And now we are ready to print the values, table values. And this is good. And actually we will do it like this. And we will say printf %c, and if the flags I value, then we print an x, otherwise we print nothing. Well, we still print a space because we need to make sure that everything is aligned as it should be. Okay, I probably made 300 mistakes in this code. Can I do like puts? Whatever. Let's just printf %c. I think I can feel it somehow with printf. I need to look into that. But for now, this is not important. It's also it's debug code, so who really cares? But I continue to do speed, whatever. Later on, I'll come back to and fix this stuff. Alright, I forgot to put a new line here. Interesting. Well, I guess only if flag is set and if is interrupt enable flag. All the other flags are not set in this case, or I screwed up this table somehow. Just out of curiosity, I will say one or, so to check that it actually works correctly. Yeah, so the printing seems to work just fine, and we have stuff here. Great. Actually, we don't even need this kind of stuff anymore, but whatever. This is fine. We have the printing, we have the flags. This is a good point where we can commit the code. I do not remember at all which episode are we on. Apparently 154. So and git commit -m episode 155, and that would be print out register state on exception. So that's pretty neat. I think one last thing I want to do today is to be able to trigger this printing anytime I want. And later on, we will again work on a proper debugger, I hope. But for now, it would be nice if we could just trigger this at any location in code that we want. And the way I want to implement this is with this code. So you have exception breakpoint, and that, in my understanding, is triggered anytime the CPU comes across, or x86 CPU comes across CC instructions, so interrupt 3, and we'll end up in this branch. But we don't want to actually consider this an exception. Well, let's take it one step at a time. First, let's figure out how we're gonna actually do it. And my idea is to use the code that we already have, so don't touch the compiler, but implement it in more or less in userland. If you have coded with JavaScript, you might have seen there is this debugger instruction, and I'm not sure if we already have it. No, we don't. That's great. So we don't have this debugger instruction. Maybe I called it breakpoint. No. Okay, so we don't have it. That is actually great. We'll come back here. We'll go to prelude.mass, and we're gonna just try to add it here. And the way I want to add it is, I will say macro. So if it is a macro, no, I need a syntax statement. So I need to do it like this. Syntax statement here would be just debugger as a single thing. And what this will do is it will do this stuff, inline machine code bytes. So I know the code for the instruction, it is CC. So that's exactly what I will do. I'll say 0x CC. Right. First of all, let's try like that to make sure that the actual definition of the macro is correct. That seems to be the case. So that's good. And now we should be able to use this in any code that we want. First of all, let's unfocus the test that was focused. So this one, we are no longer interested in this. Instead, let's go and look at our favorite example of FizzBuzz. Let's run test to see that it still works. It indeed does. So now I should be able to go to that example and I should be able to put a debugger in any place. Well, let's put it right in front and we'll say debugger. What should happen now, I think, is that we will get a very shallow stack trace and then the program will crash. This is my understanding of what's supposed to happen. But let's see. Yeah, so as you saw, we crashed. And the reason we crashed is because we tried to search up in the code for a handler and we couldn't find one. So in the end, the process had no real option except for crashing. Okay, but as I said, we end up where I expected, which is user breakpoint. So this is this code, exception breakpoint. Great, so that stuff works, which is pretty neat. And when we get to exception breakpoint, what I want to do is, well, I guess first of all, I want to move this /n into each of those. So they can remove it from there and make it slightly nicer. Okay, so now we can remove it here and I can do the following. I can print it. Actually, first I will do, say, user breakpoint. Then I will print the thing, but the difference with the undercode will be in this case. So by default, we don't want to actually do anything with the exception. We just want to print the information about it, and then we want to propagate it up. Like this language by default is not supposed to have exceptions. So this is a good thing to do and just let the program crash. But for the user breakpoint, we actually don't want to crash. What we want to do is do some custom handling. And right now, all that handling will be to print the state of the registers, and then we will use this exception continue search, or continue execution, sorry. And if I'm not mistaken, that should allow us to do what we want. I'm not sure if I need to adjust the address. It might be that I will need to adjust the relative instruction pointer, but we'll see. If I end up in an infinite loop, then I know what is happening. So here I will do this, return exception continue execution. So now what should happen is we should get the printout, but instead of crashing, the example should keep working. Let's see if that is the case. And that is not at all what happened. That is kind of not great. So I think I need to adjust the place. Dispatcher context control PC provides IP after the instruction that caused the exception. without instruction. Byte size before comparing. Interesting. So that should not be required, I guess. Out of curiosity, what happens if I do context record rep plus equals 1? Because CC is just 1 byte. If that doesn't work, then we are in for some pretty bad debugging. Okay, so that did work. Great. Move in move instruction pointer over the CC instruction. Great. So that's exactly what I wanted. Now you can see we have printed the state of the registers, and we still our program still worked correctly. We can actually do it every loop. So for example, I could put it here, and we should see a lot of them, like 100. If everything's fine, that's exactly what's going to happen. And apparently that is not the case. Interesting. I wonder what it is connected with. Well, let's try to run it in the debugger. I probably will not spend too much time on this because this is not how I plan to use debugger instruction anyway. I just wanted to sort of show what it does and how it works. But we will continue working on debugger later on, so we'll see. We'll get there. Okay, so we have triggered the CC. Fine. What now? F11. So this is okay. So the first iteration of the loop is perfectly fine. But for some reason, it is unhappy when we come across it again, right? This is what happens. Yeah, that was the wrong one. So, okay, so when we are running with the debugger, we actually don't get to our code. Huh. That's going to be very, very annoying to debug. So I don't think I will dive into that just today. Maybe I need to read up a bit more on this, but the basics work. Just as a final test, let me try to put it outside of the loop and still do it twice. If I understand correctly, that will still crash, but we'll see. Yeah, so something about doing it twice that does not seem to work. It might be literally connected to our code here and some stuff that I'm not correctly restoring or something like that. But again, yeah, I'll look into it later and then we will go from there. For today, that is about it. Thank you very much for watching and hopefully see you next time.